Hi everyone, my name is Marvin Sendikadiwa, and this is my Tulip presentation. So we have a data set for chess players and the games that each of these chess players played. We have also information that is linked to these participants, for example, the birthplace, their name, and the number of participations, their peak rating, and the status. So this status, it's a code, 0 meaning it's someone that participated in the World Chess Championship, but they didn't reach finals. Then 1 means that it's someone that reached the finals, but they lost. Then 2, it means it's a former world champion. So let's take a deep dive into our first visual. So the first visual, it's a map. So since we have the birthplace for each of these candidates, we can see where they originate from. For example, we can see that Robert Fischer is from the United States, and we have some people from Russia as well as other countries. So we can see that there's a lot of concentration within this region. And this is the European region. So it means a lot of people in that region participate in the game of chess. We can also see that there are color codes, that is green, blue, and red, and also of different sizes. So green means that that participant is a former world champion, and blue, it means that that participant reached the finals but lost, and red, it means that that person, they only participated in the event but they didn't go too far. So this is it about how the different players are located. So let's take a deep dive into the next visual. So okay, so this next visual, it shows the relationship between these different players and the number of games they played against each other. So this is a circular view, but it's a type of graph view, but it focuses on having participants on the nodes, on the outline of the circle, while the interaction between these two nodes is in the center. So this could be a much better view in a way that you can easily see the connections from a particular node. Okay, so let's take a look at another representation of that same data. So we have a node link diagram, and this is how it looks like. So it still shows connections between the different players, which are games, and we can see that all the players in green, they have a lot of games they played. So these are world champion. To become a world champion, it means you have to play a lot of games. And for players, for example, like this one, we can easily see that they only have one game or a few games that they played, and probably they lost it and they were knocked out eventually before they could progress any further. So let us take a deep dive into another visual. So okay, this is the adjacency matrix, and the adjacency matrix, it's a mathematical representation of the relationship between different nodes. So it's a matrix, as you can see, and it shows how this data point connect to the data points this side. So the number of vertices is the same as the number of these horizontal nodes. So let's add labels and see. Okay, as you can see, so these nodes are the different players, and this is the relationship. So a lot of so we can see that there's a lot of world champion this side, former world champions, and yeah, we can really see the relationship between the two different players in another point of view. So that is it for the adjacency matrix. Let's take another let's open another visual and get to see what it represents. So we have the scatter plot next, and the scatter plot we have three scatter plots. The first one representing the peak rating per participation. So here we have the number of participations, and then here we have the peak rating. So we can see that a lot of former world champion, they have peak ratings, okay, and we can see that a lot of people that are actually dropped out, they have a rating lower than around this. So we can easily see the relationship between the peak rating and the status, whether the person is won the championship or they didn't advance any further. So we have also different views for this different scatter plots that represent different views, but that is it. So let's open another visual. Okay, so we have histogram next. Let's see what the histogram tells us. So we have three histograms still, and in this histogram we have the number of participations. As you can still see, we are maintaining our color coding. So a lot of world champions have high participation as compared to people that dropped out. As you can see, almost whoever participated once, they dropped out, and then almost whoever participated twice, they either dropped out, or we can see some bit of blue here, so meaning they reached the final but they lost. So we can still get more insights between the two, between these data points. So this is still a histogram that represents that a lot of players that have the highest ratings almost end up being world champions. And we can see that a lot of players that failed to win a world champion, that is, they reached the final, but they failed to defeat their opponent. They have almost an average rating. We can see a lot of blue within this place. And so yes, that is what the histogram tells us. So let's get to see another point, another visual. So we have a self-organizing map, and ultimately what a self-organizing map is, it uses machine learning and deep learning algorithm to kind of arrange this data into how a computer interprets. So the computer is able to tell the relationship between the different data points, and it plots the data accordingly. So it's a visual representation of basically the computer's brain. And one of the graphs that stood out is the peak rating. So we can see that a lot of people with peak ratings, they tend to be, they are green. So this is peak rating. So this is rating at the bottom. You can see that the peak rating, which is around 2,800 and above, we see a lot of green here. And from our color coding, remember that green was from our world champion. So ultimately, we've been able to see the different the relationship between the different data, and from how I can conclude this is that in as much as a lot of former chess world championship are coming from Europe, there is still these people that reach finals and fail still coming from Europe. So it shows that Europe is still reigning when it comes to playing chess. And still in the future, in the foreseeable future, it will be Europe having world champions as compared to the other. As we can see, the only world champions that we have outside of the European region is only Robert Fischer, which is from the United States. So yes, that is it from me. Thank you very much.